Hello everyone, how are you all? I hope you are keeping fine and safe in this pandemic situation. Just stay home, stay safe, stay healthy. So let's start the video today. Students, in this video today, we are going to discuss about calendar. Let me write down the topic. Now, under this topic calendar, we are going to obviously know a lot of things, but this calendar topic comes for various type of banking or government exams, and it comes under logical reasoning. So let's begin with it. I'll give you a brief introduction of calendar. Calendar is one of the most important topics for government sector entrance examinations. The topic calendar falls under the category of logical reasoning, as I already told you. But since it involves logical discussion, analysis, and interpretation, so it comes under logical reasoning. You can definitely expect 2 to 4 problems in the question paper of various government and banking exams from this particular topic. Now, coming to which exams ask you questions from the calendar. I'll give you a chart of it. The following exams ask you questions from the calendar topic under the section logical reasoning. Firstly, SBI. You know, SBI PO or probationary officer is a kind of exam. So SBI PO asks you questions from this. The second is SBI clerk. The third exam is SBI SO or SBI Specialist Officer. The fourth exam asking you questions from this is IBPS PO. The fifth exam is IBPS Clerk. The sixth exam is RRB. The seventh exam asking you question is IBPS SO. And the eighth exam asking you question from this calendar is SSC or Staff Selection Commission. You can take a screenshot of this since I'll just erase this. Since I have already discussed what are the examinations asking you questions from calendar, I will start with the introduction. What is calendar? A calendar is a chart or series of pages showing the days, weeks and months of a particular year or giving particular seasonal information. We all have calendars at our home. Now the topic that falls under the calendar section that I am going to discuss right now. Firstly, a basic structure of a calendar and the concept of an odd day. Now what is odd day? I will explain further on. Secondly, questions relating to decoded days of the week. Thirdly, from this calendar you might expect evaluation of a leap year. Now what is leap year and its sums I am going to discuss later on. Fourthly, evaluation of odd days in a century. Fifth, you might be asked for type 1 problems. What are type 1 problems? Finding the day when another day of the year is given. That is type 1 problem. Now coming to type 2 problem, what is it? Finding the day when another day of the year is not given. That is type 2. Now coming to type 3 problems. Type 3 problems are matching the calendar of a month. So these are the problems you usually get from the chapter calendar. Now, basic structure of a calendar. What is it? Firstly, you have ordinary year where any year has 365 days is called an ordinary year. Example 2009, 2019, etc. Leap year, secondly. Any year which has 366 days in it is called a leap year. Example 2012, 2020, etc. Now, the division of a number 365 by 7 gives you the quotient 52 and the remainder is 1. If you get that, then that indicates you are having a normal year. And that one extra day is called the odd number of day. Okay, so that is the ordinary year. Now for the leap year, if you talk about the leap year, it's just the other way. The leap year has 366 days. Now for the ordinary year, which I told you that one extra day is called the odd day. Throughout the calendar topics, you might get questions from this odd day. Now leap year has 366 days, and 366 days, if you divide by 7, you get 52 and the remainder is 2. Now, this 52 indicates the number of weeks and 2 is the extra days that we have. So, this 2 extra days are the odd days of this leap year. This is for leap year. These 2 extra days that I have written down here are also referred to odd days or odd number of days. Therefore, in an ordinary year, there is only one odd day, whereas in a leap year, it has 2 number of odd days. Now, the concept of odd day, the number of odd days in a month. January has 31 days irrespective of whether it is an ordinary year or it is a leap year. The division of the number 31 by 7 provides the remainder 3. Hence, January has 3 odd days. Now, this is the concept of odd year, odd day irrespective of leap and non-leap year. On generalizing, any month which has 31 days has 3 odd days, and any month which has 30 days has 2 number of odd days. I'll just erase this. Now, the only exception happens is in the case of February. The February month has an ordinary day of 28 days. Division of 28 by 7 provides 0 as remainder. Remainder is 0. Hence, the number of odd days in February of an ordinary year is 0. But for a leap year, it has one odd day, as February in a leap year has 29 days. Remainder comes to 1. Now, the odd days in different months of a calendar here are, I'll be giving you that, so you can just take a screenshot or write it down. January has 3, February has 0 or 1. March has 3. April will have 2. Coming to May, May will have 3 odd days. June will have 2 odd days. Coming to July, July will have 3 odd days. August will have 3 odd days. Coming to September, September will have 2 number of odd days. October will have 3 odd days. Coming to November, November will have 2 number of odd days. Finally, December will have lastly 3 number of odd days. So these are the odd days table that I have given you. This is really very helpful. You can take a screenshot. Now the coded days of the week. The week always begins with Monday. We all know this. And therefore, Saturday and Sunday is referred to weekends, which are our favorite. I am sure you must be loving your weekends. Now, in order to make the calculation easier and reduce its time during the examination, the days of the week are coded as I am going to write now. I'll erase this. Now, Sunday is written as 0, Monday as 1. 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, 6 for Saturday. So 0, 1, 2, 3, 4, 5, 6. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So 6 for Saturday, and that ends our week. You can just take a screenshot of this again. Now, this table helps in the decoding of the answers obtained at the end of the problem solving questions or process in the calendar topics. I'll erase this. Now comes the topic of day gain and day loss. So this concept I am going to discuss right now. +1 year. When we proceed forward by 1 year, then 1 day is gained and vice versa. Example, 9th August. Now 9th August 2013 is a Friday. Therefore, 9th August 2014 has to be Friday +1, that is Saturday. Clear? Now if we go back, then the process gets reversed. 9th August 2014 is a Saturday. Therefore, 9th August 2013 has to be Saturday -1, that is Friday, according to the coded and decoded the number of days in a week that I have taught you right now. Now, +2 for leap year. When we proceed forward by 1 leap year, then 2 days are gained and vice versa. Example, if it is Wednesday on 10th August, Wednesday for the year 2011. What will happen? Then if we add +2 to it, it will be Wednesday +2, that is Friday for 2012. So according to the concept of leap year and non-leap year, if this is a non-leap year, 9th August 2013 is Friday. For non-leap year, what we do? We add +1 odd day, that is 9th August 2014. What it will be the day? Friday +1, which is Saturday. Now coming to the cases of leap year, I have already told you we do +2 or -2. This is for normal year and this is for leap year. For leap year, since we do +2, if 10th August 2011 is a Wednesday, the next year 2012, which is a leap year, will have 10th August +2. So Wednesday +2 is Thursday and Friday. So Friday. So 10th August 2012 will be Friday. Now proceeding to the next part of our discussion. Now the next discussion that I will do is the reverse of the leap year is also possible, as I told you, in case of non-leap year. The reverse is also correct, which is if 22nd April 1988 is Friday, then 22nd April 1987 is Wednesday. That is -2 days. So you can just do this in your rough copy and you can understand. Now there are exceptions to leap year, day gain and day loss. The date must have crossed 28th February if the coming year is a leap year for adding 2 days. Otherwise, add 1 day. For example, if 26th January 2011 is Wednesday, then 26th January 2012 would be Thursday. Even if 2012 is a leap year, we have added +1 because 28th February is not crossed. Now talking of March. If 23rd March 2011 is Wednesday, then 23rd March 2012 would be Friday. +2 as 28th February of the leap year has crossed. Right? Now coming to the concept of leap year. A normal year has 365 days. A leap year has 366 days. The extra day is the 29th of February, which is added in Feb. A year which is divisible by 4 is a leap year, except if it is divisible by 100. Then we have to check if by dividing by 400. For example, 1988, 2008, 2016, etc. all are leap years as it is divided by 4. But 1600, 2000 are all leap years divided by 400. 100 plus 4. Now 2200 are not leap years as they are not divisible by 400 even if it is divisible by the number 4. Now evaluation of the leap year. The leap year occurs every 4 years, most of the time. But there are scenarios where the gap between 2 leap years was 8 years instead of regular 4 years. Example, the year 1896 is a leap year. The next leap year comes in 1904, since 1900 is not considered as a leap year. In order to make the investigation easier and faster, any year which is divisible by the number 4 completely, remainder becoming 0, is considered as a leap year. Just register this. Example, 1888, 2012, 2016 are leap years as it is completely divisible by 4. Years like 2009, 2019 are not divisible by 4 completely since they are normal years. An exception, a year 700 is completely divisible by 4, but it is not considered as a leap year. For a century here, keep this in mind, the logic follows that it should be always divisible by 400, not by 4. Even though the year 700 is divisible by 4 but not by 400. So 700 cannot be considered as a leap year. Example, 400, 800, 1200, etc. are leap years as they are divisible by 400, and the years 300, 700, 100, etc. are not leap years as they are not divisible by 400. I hope the concept is clear of this leap year. Now coming to the evaluation of odd days of a century. Now this concept helps students in answering the questions of calendar in less than 30 seconds, and this is my guarantee. The question looks unsolvable, but trust me, the application of these concepts which I have just taught will make it easier to solve it in just a quicker way of few seconds of time. Coming to the sums. Let me write the question for you. Before that, I'll erase this. First question, what day of the week was year 100 AD? December 31st. And this is your question. Now coming to solution. Let's consider the first 100 years, first AD to 100 AD. First, now dividing the first 100 by 4, we get the first 100. From this we get 76 ordinary years and 24 non-ordinary years. The quotient when 100 is divided by 4 gives 25. But the year 100 itself is not a leap year as it is not divisible by 400. Hence 24 is considered instead of 25. So coming to step 1, I will write the answers in steps. So 100 years gives you 76 plus 24 non-ordinary years. I'll erase the question for you so I can write the answer. So I'm giving you the solution. Step 1. Hundred years is 76 ordinary plus 24 leap years. Now, we know that an ordinary year has one odd day and a leap year has 2 odd days. Right? Hence, 76 ordinary years will have 76 odd days and 24 leap years will give you 24 into 2, that is 48 odd days. Right? Adding both the results, we get 76 plus 48. That will give you a total of adding 76 into 1 plus 2 into 24 will come to 124 odd days in total. Right? Now, the step 2. Step 2 is 100 years. 100 years will have odd days, that is 124 odd days that we have discussed. Dividing the total odd days, that is 124 by 7, gives you the quotient as 17 and the remainder as 5. Now this indicates 124 days will have 17 weeks and 5 odd days. Right? The number of odd days that we are getting here is 100 number of days. Now coming to the step 3. After we have finished step 2, we will go to step 3, which is 100 years. 100 years, which we know is 17 weeks plus 5 odd days. So a number of odd days in the 100 years is 5. Right? So after we know this, now we will decode the number to the days of the week, which will give you the result that the number 5 stands for Friday. According to the table, if we go by the table, 5 stands for Friday. Hence, the last day, December 31st of the year 180 was Friday. With this, I will end the first part of my video. In the next video, we will come up with various other sums. So, ending my video here, I hope you will stay safe and fine. Thank you. Keep watching.